Hi everyone! Today we're going to learn how to find the derivatives of exponential functions that have other bases. So our learning goals are to learn to find the derivative of exponential functions, so functions that look like y equals b to the x, where b is a number other than e because we already know how to do e. So it could be 2 to the x, 3 to the x, 5 to the x, etc. And then we're also learning to differentiate functions of the form y equals some number base to an exponent that's a function of x. So we can prove that the derivative of an exponential function with a base b is as follows. So if f at x is b to the x, then f prime at x, or the derivative, is b to the x times the ln of b. So this is how we're going to do it. We're going to start off rewriting the function as y equals b to the x. And then when we have an exponential function, we can use log rules. We could take the log of both sides, but we're actually going to take the ln of both sides, which if you remember is log to the base e. So I'll first write it as log to the base e, just so you remember that ln means log to the base e. So then I can write log to the base e of y is the ln of y, and log to the base e of b to the x as the ln of b to the x. Okay, so now I just want to use the exponent rule, or the logarithm rule, which says that if I have the log of something to an exponent, I can bring that exponent out in front. Okay, so none of this has been deriving at all, okay? All of this has just been changing from exponential form into logarithmic form, and then deciding to use, and then writing it with ln instead of log to the base e. So we've just rewritten it from exponential form into logarithmic form. That's what we've done so far. So it means the same thing. So we changed from exponential form to logarithmic form. And then we used a law of logs where we can bring that exponent down. So now I'm actually going to derive, okay, and I have to derive with respect to x. So that this next step from here to here is derive with respect to x. So if you remember, the derivative of the ln of y is going to be 1 over y, but because it's with respect to x, you have to multiply by dy by dx. So the derivative of the left side is going to be 1 over y times dy by dx. The derivative of the right side, so this is like having this ln b here is just a number. Okay, so it would be, if I wanted to write it differently, I could write it, so sorry guys, just remember, if I wanted to derive 2x, the answer would be 2. Ln b is just a number, so you can think of x ln b as ln b being the number out front of x, and then the derivative would just be the ln of b. Okay, so the derivative of x ln b is just the ln of b, and the ln of b is just a number. So I want to get dy by dx by itself because it is the derivative, it's y prime, or f prime at x, okay? And to do that, I need to multiply both sides by y. So I get that dy by dx is ln b, I'll write the y in front actually, y times the ln of b. Again, the ln of b is just a number. But what's y defined to be? So asterisk or star, y is b to the x. And what does dy by dx mean? That means y prime. So y prime is, replace y with b to the x, ln of b. So we've just proven then that if f at x is b to the x, then f prime at x is b to the x times the ln of b. So I think of it as, we know for instance that if y is e to the x, then y prime is e to the x. But if you don't have that perfect base e, your base is some other number, you have to multiply by the ln of b, which is just a number that corrects for the base not being e. That's how I thought of it when I was in high school. Okay, and if you apply the chain rule to that, so if you're deriving y equals b to the g at x, then y prime would be b to the g at x times the ln of the base times g prime at x. Okay, and we're going to start off with some easy ones so you can get used to this. This looks like a lot, but really this is my outer derivative, and then times the inner derivative. And it's just, you have to remember this, that you repeat the exponential function, but then you have to multiply it by the ln of the base, because if your base is an e, and then times the derivative of the exponent, okay, or your inner derivative. So this is the chain rule. That's side here. Okay, so if we wanted to differentiate y equals 5 to the x, y prime would be 5 to the x times the ln of 5, and then the derivative of x is 1. So we didn't need the chain rule for that one, and that would just be your answer. Remember, this is just a number. If you wanted to know what it was approximately, you can use your ln button. Ln of 5, it's approximately 1.6094379. Okay. Y equals 3 to the 4x. So y prime, this one is going to involve the chain rule. So I repeat the exponential part, 3 to the 4x. Then I multiply it by the ln of the base, 3, which is just a number. And then I multiply that by the derivative of 4x, which is 4. And again, this is three numbers multiplying, terms multiplying together. 3 to the 4x, there's an exponential function. Ln 3 is just a number that you could figure out on your calculator. And then 4 is just 4. So 3 parts multiplying together. 2 of them are just plain numbers, but that's not the ln of 12. A lot of people make that mistake. Ln of 3 is separate. So brackets, use brackets to show that they're different. Okay, so this is 3 to the 4x times the ln of 3 times 4. All right, f at x is x cubed plus 3 to the x. So this type of question, they're trying to make sure you know the difference in how you derive those. So f prime at x, the derivative of x cubed, that's way back to the power rule when we were first starting the rules. So the derivative of x cubed is 3x squared plus, so the derivative of 3 to the x from today is going to be 3 to the x times the ln of the base. And that's your derivative. dy equals 2 to the power of 3x squared plus 5x. So y prime is going to be, so repeat this, 2 to the 3x squared plus 5x times the ln of the base times the derivative of the exponent, which is 6x plus 5. And that's how you would keep it. So y equals 10 to the x over x. So you're going to see that as a quotient rule. So the first function, the function in the numerator is 10 to the x, and the second is plain x. The derivative of 10 to the x is 10 to the x ln of 10, and the derivative of x is 1. So y prime, according to the quotient rule, is going to be derivative of the first times the second. So 10 to the x ln 10 times x, derivative of the first times the second, minus the first times the derivative of the second, all over the second squared. And we can do some simplifying here, because if we look at these two chunks, they both have 10 to the x in common. So we can common factor out 10 to the x, and then we would get, probably write it as x ln 10, so you don't need the brackets. So if we divide this first chunk by 10 to the x, you get ln 10 times x, or x ln 10. minus 10 to the x divided by 10 to the x is 1 over x squared. And that's as simplified as you can make it. So the next one, we also have two functions multiplying together, the simple function x and the function 5 to the square root of x. So we'd probably rewrite it first as x 5 to the x to the half, and then make our chart. So the first function is x, and the second function is 5 to the x to the half. So the derivative of x is 1, that's easy. The derivative of 5 to the x to the half is going to be, so 5 to the x to the half times the ln of the base times the derivative of the exponent, which is 1/2 x to the negative 1/2. Is there any nicer way to write that? We'll see. So I could write this as 5 to the root x ln 5 times 1/2 x to the negative 1/2. All right, so f prime at x then. Derivative of the first times the second, so that just gives me 5x to the half. And then this is product rule, so it's plus the first times the derivative of the second. So I can see I'm going to have the 5 to the root x, and then the ln of 5. So this and this. And I'm going to have the 1/2. And this. But here I'm multiplying powers that have the same base. So if I think to myself, I'm multiplying x by x to the negative 1/2. So x times x to the negative 1/2. You're going to keep the base x and add the exponents. So x to the 1 is really x to the 2 over 2 plus negative 1 over 2, which is going to give me x to the half. So when I multiply those two together, I actually get x to the 1/2. All right, so now we want to put it in simplified factored form. So notice here how I have 5, these are my two chunks. So one chunk's pretty small and then one chunk's got all this stuff in it. So here I've got 5 to the x to the 1/2, which I could really write as 5 to the root x. So each chunk has a 5 to the root x in it. And we always said that if we have a fraction in one of our chunks, we want to factor that fraction out as well. And that's then all that they would have in common. So there's our common factor. So the 5 to the root x divided by 5 to the root x gives me 1. But here, so we have an invisible 1. 1 divided by 1/2. So can you still see here? 1 divided by 1/2 is 1 times 2 over 1. If you use a fraction rule is 2, or you think half goes into 1 twice. So 5 to the root x divided by 1/2 times 5 to the root x is going to give me 2. So this chunk divided by the greatest common factor gives me 2. Plus 5 to the root x divided by itself gives me 1. The half divided by the half gives me 1. So I'm going to have root x times ln 5. Oops, square bracket there. And then we might choose to write it as what's going to be in the denominator, just the 2. And in the numerator, I'm going to have 5 to the root x times 2 plus root x ln 5. So that would be how it would look in simplified factored form. Okay, G, y equals 2 to the negative x times e to the x. So again, we've got two functions of x multiplying together, so we're going to need to use the product rule. So first, second function derivative, so 2 to the negative x and e to the x. The derivative of 2 to the negative x is going to be 2 to the negative x ln 2 times negative 1. And the derivative of e to the x is just e to the x. So y prime is going to be, so derivative of the first times the second, so I'll put my exponentials at the front. So 2 to the negative x e to the x times the ln of 2, which is just a number, times negative 1, which is just a number, plus the first times the derivative of the second, so 2 to the negative x times e to the x. And again, if I want to put it in simplified factored form, now I have two chunks, and they both have 2 to the negative x e to the x in common. So if I divide the first chunk by that, I'm going to get negative 1 times ln of 2, you can think of as negative ln of 2. Just put the negative 1 out front, and the 1's understood. Plus 2 to the negative x divided by itself is 1, e to the x divided by itself is 1, so plus 1. And that's the answer in simplified factored form. Some textbooks might, even though they gave you a negative in the question, I would totally accept a negative in the answer, but you might look in the back of the book one day and see that they wrote it as e to the x. They might write this as 1 minus ln 2 just because it looks prettier without a leading negative in the bracket, and then change 2 to the negative x in the numerator to 2 to the positive x in the denominator using the negative exponent rule. But I would totally accept that as the answer. Okay? Being able to know that these are equivalent though, especially a lot of tests in first year university are multiple choice. So you might get this and you have to then look at your answer, the 4 answers, that's not one of them. You have to realize this is the same as your answer. All right, H, it's just a sum of functions, so we don't have to use the product rule or the quotient rule. So just derive them each on their own. So h prime at x. So the derivative of 3 to the 7x is going to be, repeat 3 to the 7x times the ln of the base times the derivative of the exponent plus the derivative of the ln of 3x is 1 over 3x times the derivative of 3x, which is 3. And there's not a pretty way to write that. Just make sure you use brackets. And don't do ln of 21 because that's not true. And then 3 over 3x is the same as 1 over x. And they don't have a common factor. That's the derivative. Not pretty, but you found the derivative. Okay, I, f at x equals x squared over 2 to the x. So we've got a definite quotient rule going on here. So the first is x squared and the second is 2 to the x. The derivative of x squared is just 2x. The derivative of 2 to the x is 2 to the x times the ln of 2. So f prime at x using the quotient rule is going to be derivative of the first times the second. So 2, make sure that x is like the regular size one, times 2 to the x minus, so we've got an x squared, a 2 to the x, and a ln of 2 all multiplying together, all over the second, which is 2 to the x squared. So then we're going to factor in the numerator. So in common with these two terms here, x, yes, x and x squared, so an x, and a 2 to the x. So if you divide the first blue chunk by x 2 to the x, you're just going to get 2 minus, if you divide the second chunk by x 2 to the x, so x squared divided by x is x, 2 to the x divided by 2 to the x is 1, but we still have the ln 2, over, and then power to an exponent rule says you keep the base and multiply the exponents. And then we have clouds, because we have 2 to the x and 2 to the 2x, so the same base, and we're dividing the powers. So that's going to give us x, 2 to the, so you're thinking 2 to the x over 2 to the 2x is 2 to the x minus 2x, which is 2 to the negative x. Okay? So when you divide those, you're going to get 2 to the negative x times 2 minus x ln 2. And then because the question didn't have a negative exponent, you don't want your answer to. So you could write it as x times 2 minus x ln 2 over 2 to the positive x. Simplified factored form. And then for j, you see that we have a big function to an exponent, so it's chain rule first. So it's going to be y prime is, bring the 3 down 3 times, repeat what's inside, all to the 2, and then the inner derivative, the derivative of 5 to the x squared is going to be 5 to the x squared times the ln of the base 5 times the derivative of the exponent, which is 2x, plus the derivative of e to the negative 2x is e to the negative 2x times the derivative of negative 2x, which is negative 2. So there's not very much I can do to make this look any nicer. The only thing I would do is put the negative 2 out in front of the e to the negative 2x, but other than that, just make sure you've got brackets and you don't combine things that you're not able to. That would be your answer. Okay, so some applications. Our basic ones, find the slope of the tangent to that curve at the point where x is 1. So first we have to find y prime. So we've got y is 2 to the power of x over x. So that's going to be a quotient rule. So our first function is 2 to the x and our second is x. The derivative of 2 to the x is 2 to the x ln 2. The derivative of x is 1. So y prime is the derivative of the first times the second. So maybe I'll write the x first, then 2 to the x, ln of 2. There's a minus with the quotient rule, minus 2 to the x times 1, which is just 2 to the x, all over the second squared. We don't have to simplify it because we're substituting in 1. We want y prime at 1. So that's going to be 1 times 2 to the 1, ln of 2 minus 2 over 1 squared. So y prime at 1 is going to be 2 ln 2 minus 2. And again, that's 2 ln 2 minus 2. That's a number. This is just a number. If you wanted to know what it was approximately, you would do 2 times the ln of 2 minus 2, which is approximately negative 0.613705638, but you want to give an exact answer, you would just leave it like that. 2 ln 2 minus 2 is your slope. So therefore, statement M tangent equals 2 ln 2 minus 2. And our last question, find the equation of the tangent line. So that's going to be a y equals mx plus b answer to the curve y equals 10 to the x at the point 110. So y is 10 to the x, y prime is 10 to the x times the ln of 10, y prime at 1, slope of the tangent at 1 is going to be 10 ln 10. So then that means that m is 10 ln 10, which is just a number again. And our point is 110, our x and our y. Y equals mx plus b. 10 equals 10 ln 10 is x times 1 plus b. 10 times 1 is 10 times the ln of 10, which is just a number. So then we can subtract 10 ln 10 from both sides because it's just a number. So b is going to be this 10 minus 10 ln 10 number, which again we have to remind ourselves is a number. It doesn't look pretty, but it's a number. So therefore the equation of the tangent line is y equals, so m is 10 ln 10 x, so m, this is like our m, x plus b is 10 minus 10 ln 10. So that's like our b, okay? So our slope times x plus our constant. So that's the equation of the tangent line. All right.